Increasing and decreasing functions on applications of differentiation, explained by Justin D'Souza. The learning objectives of this lesson are to identify increasing and decreasing functions, and then to find the local extreme of a given function using the first derivative test. The keywords of this lesson are increasing function and decreasing function. Now let's look into the increasing and decreasing functions. Now say for example the salary is increasing. You can see it goes upwards. Something that goes upwards is increasing and something that goes down. So now debt, a loan which is taken, you're giving it back and you want to clear it. In time you have no debt, cleared all your loans. So this is decreasing function. So in any graph, we can find out increasing and decreasing functions with various ways. And derivative is one of the best and the appropriate way to use in complicated problems. We will see how we do it in this video. Now, this is basically explanation of how we solve and how we do it. We need to know the information of the previous lesson that was on critical numbers. We need that concept, the first derivative, finding the critical numbers. And then there is an extra step which we will study in this lesson about increasing and decreasing functions. The definition 4.1 tells us about increasing and decreasing function. Now let us understand, if a function is increasing, now say for example an interval I, for every x1 and x2 which belongs to this interval, these 2 points are in this interval. And now look over here, they have told the first interval x1, the first point, sorry, is less than the second point. And also in the function, the graph, the f of x1 is less than f of x2. And f of x gets larger as x gets larger. That means it's increasing, the function is increasing. Now I will draw it. See, x is getting, that means it's going on. Now here, this particular point, imagine this is the x1 point and x2 is bigger than that. Now the graph over here is also less. This is less and this is more. This is the graph, right? This is increasing. This is what it states. x1 is less than x2. Now x1, x2 and f of x1, f of x2. This is increasing. Now this is just definition, technical terms. But if you understand it's, if 2 points, it's going upwards. That's it. Okay. Now what about decreasing? Now if it is decreasing, then it's the same thing. These two are same points x1, x2. But you might have guessed it by now. This point must, whatever it is, must be greater than the next point. That's it. Now look over here. Yes, see here it's clearly mentioned. F of x1 is greater than f of x2. That's the only difference. That's it. This is increasing function up above, down is decreasing. And this is another important thing, because we are going to do differentiation. This is on application of differentiation. Now, what do we get by differentiating? Now, imagine you differentiate a function. This is important. You differentiated a function and whatever the value is greater than 0. That means, now we will see in a while in the graph, when you derive f dash of x means derivation of the given function, and this part is greater than 0. That means it's positive. That's it. Greater than 0 is positive. This is positive. Greater than 0 means increase. We know positive means growth and that is increasing. Whereas if f dash is less than, f dash of x is less than 0, then f of x is decreasing. Negative is decreasing. That's the only things we need to remember over here. And now you can see over here, f of x, see, this is the function, you can see is increasing. But what is the slope? Derivative f dash means what? Slope of the tangent line. What is the slope of the tangent line? It's positive over here. Here it's positive. Look over here, wherever it's decreasing, the slope is negative. Can you see this negative? And this one is also negative. Why? Downward slope. It'll be minus something. All the other sides, if it's increasing, it'll be positive slope. That's the only thing. So now over here, I will tell you how easily you can draw the graph of the function. See, that's what they want. Draw a graph of function f of x showing all the extrema. Now we can easily find the increasing, decreasing, and graph it. Now the step one is just derive the given function. What is f dash of x? When you derive this, what do you get? 3 comes down, it will be 3 times 2 is 6x squared plus 18x minus 24. This is the derivative, right? Now you need to take your calculator and find the critical points, which we did already before. F dash of x must be 0 or the derivative must be undefined. Undefined. This is the conditions. Here critical points exist. Critical points exist. Critical points are there. Exists. Okay, the critical points doesn't mean it's maximum or minimum points, absolute maximum or local minimum or maximum. No, they just give you some importance. There might be maximum or minimum, or maybe just a false alarm. It's like that. Okay, so this is the thing. Now let's take out our calculators. All you need to do is press more phi for equation, and this is quadratic, mod phi and 2. Sorry, mod phi, no, 3. Okay, mod phi 3. Now, what is the first term? A is before x squared, that's the coefficient of x squared is 6. Then we have 18, and lastly, the constant term is minus 24. The x value is 1 and minus 4. Let's write the x values over here. 1, x is equal to 1, and x is equal to minus 4. Okay, these are important points because over here there might be maximum or minimum x minus 4. This is the step one. Now here they have told for there's no particular closed interval. It's an open interval till minus infinity to plus infinity. All the domain is considered. Okay, so in such cases what you do is, first here I will just draw a figure, just draw a straight line. Write these 2 points in ascending order. The first point will be minus 4, the second point will be 1. Okay, this is the first step. Okay, now what next? We are just talking about this derivative. We need to check what's happening with the derivative, whether it's positive or negative. Now don't put these points. If you put minus 4 here, you will get the answer 0, because that's what we did. We this cannot be undefined. It's a polynomial function. We equated f dash of 0 and solved these 2 points. These are the critical points. Now here what we do is take any point from this range, or in this between range, or the next range. See, there are 3 intervals over here. From here, the first interval, second, third. So choose a random number. What I would consider is whichever is just before this, because it goes until infinity, minus infinity. You can choose any number. This goes until positive infinity. Don't go to choose huge numbers like 100. Just take 2 over here. Over here, just take 1 less, minus 4. You can even take minus 10, minus 20. You'll get the same plus or minus. It doesn't matter. Now in the middle, you can choose an easy number. You can either choose minus 3, minus 2, minus 1, 0. I will choose 0, which is easy. Okay. Now these are the test values which you must put in this derivative. Okay, over here, and then find whether it's positive or negative. Now we will do it in the calculator. Now what I would personally do is type this derivative as it is in the calculator. 6 alpha x squared plus 18 alpha x minus 24. Okay. Now calc at minus 5. What's the answer? It's a positive answer. We don't need the answer. It's positive, right? Plus, or like this, positive. Okay. This is very important. Now we got this plus. I will just change the color over here just so that you understand this is important for the derivative. This one, it's positive. Next, now I will just tell you over here, I did calc minus 5, but even if I take any other negative number less than minus 4, say minus 40, I will get positive. Any number, doesn't matter what, will be positive. You can try any number, but it must be less than minus 4, will be positive. Now let's take another interval. This is minus 4 to positive 1. I will show you. I will try with minus 3, which is greater than minus 4, less than 1. It's how much? Negative. So I will choose over here the sign minus. I don't choose it, it's found out. Now I will show you if I change this to minus 2, I'll get negative. If I change it to, oh, I just removed it all. Let me type it out again. 6 alpha x square plus 18x minus 24. I'm just trying to make you understand that doesn't matter which value you choose, you will get a negative answer which is between this interval. So I did minus 2, let's do minus 1. You're going to get negative. I will calculate it at 0. It's all minus. Okay? But it must be within this range. Now let's go on to the last interval, that is calc 2. What's the answer? Positive. So here I'm getting a positive answer. Let me write it. Positive. So the derivative in the first interval from minus infinity to minus 4 is positive. Here it is negative, and lastly it was positive. So what do you understand here is the given function. Now I'm talking, see, this was about the derivative, okay, f dash of x. Now let me talk about the given function f of x. Okay, this one. This is increasing in this range, decreasing here, and increasing. And in the last lesson, we had seen the critical points are the local extrema for this function. So now if I want to graph this, how would this graph look? So imagine if I have a rough estimate of the graph, minus 4 is over here, positive 1. You will not get an exact answer, but this is an approximate answer. Now I know this is cubic, right? So cubic graph will be something like this, and this is positive. If it was negative, then it would come like this. So what do I know over here is basically at this point, the derivative later on we'll do. Now we will just do this. It's increasing. Okay, it's increasing over here. Before minus 4, it's all increasing, and it stops. It's having a turning point over here at minus 4, and then it goes down, and then it is having a turning point at 1, and it goes up. This is the basic information of the graph. Now if I have to draw the derivative, how would it look? At this point, it's going upwards. I know the derivative is quadratic, so it's a parabola. And now what happens in the middle? It's negative, so it's downwards, something like this. Now this is not at all accurate. I've just done a rough one. If you want to know what is this point, just put this minus 4 over here and you will get the exact point what over here the value will be. Okay, just put minus 4 in this given equation and you will find a value. Maybe it's 2 or 3, and then you can draw a more accurate graph. But I've just drawn randomly. Let's just check our graphs anyways. Now this is all the explanation, and you can see over here. See, this is the thing what we did over here. The above one is of the derivative, the below one is of the given function. And you can see the graph over here. This is the given functions graph, f of x. See why? It was something like this. See, now I have never checked the value. I did not put minus 4 and get, but you can do it. You can put the minus 4 over here. You will get value of 100. Okay, this will be 100 point. Then it goes down. You will get this also. Just put 1 over here in this function and you will get the answer over here. And for the derivative, which I've drawn over here, parabola in blue, that's the same thing. It's not accurate, but you can just put the values and you can find it more accurately. But derivative is not the one. You have to just draw this graph. This derivative, I just did it for your understanding. This is not required, but this is important. This is how easily you can graph it. I hope this is clear. Just from this understanding, this is required. After the derivative, you need to get this, and then you can easily graph it up. Okay. Now then we will go to another problem. It is uncovering a hidden behavior in a graph. Now this is an interesting question. Let's first start solving it up. How do you do it? Step 1, derive it. So I will derive this. This is a power 4 function, but when you derive it, it will become 4 times 3 is 2al x to the power 3 plus 3 times 4 is 2al again, but it will be 120. 3 times 4, 40 is 120 x squared minus 0.6 times 2 is 12. So 1, 2x minus 1.2. This is the derivative. You don't need to do anything now. Just put it in the calculator directly. Here we have to go to mode 5 and not 3. 3 is for quadratic. This is cubic. So go to mode 5, 4. Okay, and then we will type the coefficients. First one, the next one is 120, then we have minus 0.12, then we have minus 1.2. And what are the x values? So let's write the x values here. X is equal to, okay, now this is another thing important. Critical, critical, see, numbers f dash of x is equal to 0. Why? Because this is a polynomial. It's not undefined. It's defined everywhere. So you should just equate it to 0 and solve. And what are the x values we're getting? X is minus 10. And because it's a cubic, we will have three answers: 0.1 and minus 0.1. So x is equal to, I'll write in ascending order, minus 10 minus 0.1, and lastly x is equal to 0.1 positive. Now, for now, you can just try thinking. I'll ask you a question. Did you understand uncovering hidden behavior? Can you see any hidden behavior over here? But you can understand one thing. See, look at the x value 10. It's basically an outlier in the sense 10 is a big number. And over here there are two x values which are so close. If I'm graphing like this, imagine 5, 10, this is 10. Whereas 0.1? 0.1 over here is so close that you can't even see it properly if I draw a scale of 5 and 10, isn't it? I know there is a turning point, critical number at minus 10. This is minus 10, minus 5. There is a critical number. It might either be up or down. Anyway, it will be something like this. But look at these points. They are so close. The turning points, it's so negligibly different. You can't see them properly. We will see in a while how we analyze them. But first, let's do the table now, what we did it. Draw a straight line. Write these derived points in ascending order. It's minus 10. Sorry for that. Then we have minus 0.1. And lastly, we have 0.1. Okay. But these two are very, very close because over here, there is 0 in between. And it's so close, but this is very far. But now I'm just doing a arbitrary scale. And which are the checkpoints? I can choose value of negative 11 in between them. In between this, I'll choose negative 1, and between them 0, and over here I can take 1. Now these needs to be tried in the derived equation. So what you do is go to mode and 1 and type this equation: 12 alpha x cube, then what is there, plus 120 alpha x square minus 0.12 alpha x minus 1.2. Sorry, I've typed something else. 1.2 alpha x minus 1.2. Now calculate at minus 10. Sorry, not at minus 10, the check value minus 11. Calculate at minus 11. What's the answer? We are not worried about the value. We want the sign. That's it. It's a negative sign. So the derivative is negative. Next, we need to choose calculate at minus 1. Positive. Let's do next one as well. Calculate at 0. We got negative. See, negative, positive, negative, and let's see what will happen last. And we have over here 1, positive. So it's negative, positive, negative, and last one was positive. These are the answers. We're not worried about what are the values. We are just worried about the sign. That's all we need. Now, if I draw the function, how does it behave? See, here it is decreasing downwards, then over here increase, then again decrease, here increase. This is how it works. Now then, how is this, how do we graph this exactly? Now, if I graph this, there are some problems. Which scale will I choose? So now this is the correct answer. Whatever you got is correct. Now we have to graph. Now we'll show you the graphs because this one usually requires a graphing calculator. Now, see, this is what we have got, and that's absolutely correct what we did till now. But when we graph, you can see these are the graphs. Now, these are generated from different types of calculator. But now I will tell you there is something called this one over here, the global behavior and local behavior. Now, what is this? I'll just remove everything what I've written for once. And you can see this behavior, right? Whatever we got, the same thing. So I will see this one. See, whatever we got is mentioned over here. The same thing, doesn't matter. So I'll just clear whatever I've written and we will observe these graphs, which are very crucial graphs. Why? Now, which is the correct graph? It's x to the power 4. And so, which one over here? Is this the one? Is this the one? Is this the one? Which one? It's all the three that are correct. All three are correct. Only difference is if you try to see all the 3 points, see minus 10, there is a turning point. This is minus 10 value over here. Then if you see this is called global behavior. All the values are denoted here. Minus 10, 0.1 is somewhere here, 0.1 positive, negative and positive over here. Now if you see the global behavior, this is neglected. Can you see anything over here? It's like a flat line. So global behavior in this case, though it will incorporate all these three critical numbers, is not so useful. What we need to do is a local behavior. Local behavior in the sense, we know this is the outlier. We crop the scale only till these two values. See, this is negative 0.3, negative 0.2, 0.1. See, this is the turning point. Yes, it's a maximum value. Here it's minimum value. So when we crop and see only these two local behavior, then we can get more understanding. And now look here. If you're drawing the what is this? The derivative, yes. We know derivative is positive before negative 0.1. So this is 0.1. So before that, it's positive upwards. And after 0.1, also positive upwards. Whereas in between them, it's negative, so it's down. So it's a parabola over here. This looks like a cubic. But actually, this is not the true case. Here, yes, we have cropped and we have only taken two x values. So we know that if there are two x values, then that's a cubic, right? Cubic function, derived ones will have two x values. See, this is the thing. But if we take in reality the entire thing, we understand this is again a parabola. This is x to the power 4 graph. Look, it comes like this. This is x to the power 4. Whereas if you zoom only over here, it will become x to the power 3 graph, like a cubic graph. So this is about the global and local behavior. I'll just summarize in simple words. Global behavior means all the three values, whatever the derived x values, the critical numbers we got, are considered. But the problem is, you can see this is an outlier and these are very narrow. So if we take all this in this particular scale, we don't see any more details of these two x values, which are very tiny. So we zoom into the two critical numbers, that is negative 0.1 and 0.1, and we ignore this minus 10 because in this scale we can't incorporate minus 10. Then we can only observe these two. So this is the understanding. But if you have gotten this, it's correct, and you can just try to draw a rough sketch. It's very hard to draw. Even with graphing calculators, it's hard to recognize properly. That's about the 4.2 example. Now we move on to the first derivative test. What does this test mean? Now we need to have a continuous number, and we know that critical numbers will either give us maximum or minimum, some important value, right? Or it may not be anything, okay? Now this first derivative test means we need to see what happens with the first derivative. Is it positive? Is it negative? What is happening? From the positive negative values, we can directly tell whether it is having the given function is having a local maximum or minimum. How is it? Now look over here, f dash of x is 0, greater than 0 over here, and f dash of x is less than 0 for another interval. So a to c and c to b. Now that means it changes where? Greater than 0. It's increasing to decreasing. So basically, if we graph this, starting it's increasing and then decreasing, right? It's greater than 0. Positive over here because it's increasing. Over here it's minus, decreasing. Whenever you are plus and minus, it is a maximum point. Whereas if it was decreasing, increasing, your minimum point. This is common thing, right? But they just write in derivations and just show it. But now, what if you have two same signs? Say there is a critical number over here, but you got plus and plus. That means it's just increasing. There is no local extremum. There is no local extremum. There is no maximum nor minimum. These are the three cases. We have seen these cases in the previous lesson as well. We have solved problems on that. So once you know them, this is understood easily. So now let's see problems based on this. Before that, look over here. Increasing, decreasing. That means it's greater than 0, less than 0. Greater than 0 means plus, minus, maximum value. Whereas decreasing, increasing means minimum value. So, okay, this is what I just explained. In other words, you can read it out, pause and read it out. Now over here, we will solve a problem. You'll understand better. Whatever we just now did, but here, okay, sorry, this is already done. We did this example 4.1. See, remember the same question we did it. We did the graphing, and also you can just rewind back to the 4.1 example and see the detailed method what we did. So now we had done this everything already. I will just draw how we got the graph over here. We had -4 and then we had +1, and we had seen there was plus, minus and plus. Okay, and what happened over here was basically it was increasing, decreasing, increasing. Now here, look over here, there is plus and then there is minus. That means there is maximum. Where is the maximum located? At this point, -4, the graph will be something like this, isn't it? It will go like this, maximum, down, and sorry, it should go like this, minimum. That is very bad graph. We have drawn the graph in the example 1. You can just go back and see there is a maximum here, whereas at +1 it is a minimum point. That is what, from the first derivative test, we don't need to do all the graph and everything. They just want to know where is the local extrema located, right? We can directly do this and we can tell from this particular understanding, we can tell the maximum is located at -4. Yes, at -4 it will be a maximum. Whereas over here it will be a minimum point. At 1 it will be minimum. That's it. So for this exact solving of this problem, please rewind and go back to the example 4.1 and you can see the detailed solving. Here we have 4.4 example, local extrema. Now, whatever we have learned before, the same thing we need to do it. We can even graph it if you want, or you can leave without graphing, but let's try to do how much we can. First is the derivative, f dash of x. What happens? This 5/3 comes down. It will be x 5/3 minus 1. It will be 5/3 minus 1 will be 2/3, right? Yep. And then minus this 2/3, 3 times 2/3. 2/3 x. Now 2/3 minus 1 will be 1/3. Now over here it's minus. Okay, so here it will be 3/3. It will be positive. Why? Because 5/3 is bigger than 1. Here it will be negative. Now next thing, what do? We need to rearrange and write this how we can, because now this doesn't give us much sense, and since there is minus over here, that means it goes to the denominator, isn't it? Now I'll simplify and write 5 x 2/3 by 3. The denominator over here is only 3, minus this and this cancels. What remains? 2 divided by x to the power 1/3. Now here we have this denominator. Here this is the thing. We need a single term. So what do? Solve this. Whatever is the denominator, multiply up and down in the opposite sides. This over here. So 5 x 2/3 divided by 3 is multiplied with this denominator 1/3 x 1/3 minus 2 and x to the power 1/3. What do? The opposite denominator. If there was nothing, it would be 1 and 1, but here we have a number 3, so multiply up and down. So now simplify. Here x 2/3 plus 1/3, you can try and calculate. It will be power x only, because 2/3 plus 1/3 is 1, so it's 5x divided by 3x 1/3 minus 2 times 3 is 6, and over here denominator it will be 3x 1/3. Now we have same denominator, so it's common, and over here we have 5x minus 6. Don't go to simplify, this is enough. This is the derivative, but we need to have a simplified fraction. We can't have like this. We can't have separate fractions. We need to have a single fraction. Now we have a denominator, we have a numerator. In such case, there is undefined value and there is zeros. So whatever is up, denominator, make it equal to 0. 5x minus 6 equals 0. You will have x is equal to 6 divided by 5. This is the answer. Now what about this denominator? This is undefined. 3x to the power 1/3 equals 0. So x is equal to 0 directly. This is one critical number, this is one critical number. But at this point, you don't have a turning point, it's undefined, okay? The graph is undefined. But now, if you're drawing that particular graph, critical numbers are 0 over here, 6 by 5, that is 1.2 over here. And now, what's the answer? What's the check values? Let's take -1 over here. We can take 1 over here. We can take 2. Why? Because 1 is less than 6/5. 6/5 means 1.2. Okay. Now, if you're not understanding that, just use the calculator and check. Now, let's take our calculators. Here, all you need to do is check this. Now, first write this particular equation in the calculator. It is 5 alpha x minus 6 divided by 3 alpha x to the power 1/3. Now I will calculate at -1, that is our test value. What is the answer? It's positive. So I'll write plus, the derivative is positive here. Now next calculate at 1. This is negative, and last one I will do it at 2 as well. Positive. So it is plus, minus, plus. So it's increasing, decreasing, increasing. Where is the maximum? Over here, but this is undefined value, okay? This is an undefined value, undefined. This is a 0 value, okay? So now the graph basically, now you can just put the 0 over here, it will be 0 itself. So where can I graph? I'll just graph it over here. So let me just take this. And just a rough graph, okay? It's not at all accurate graph. It's a rough understanding because I'm not plugging in the values and testing. Graphing is very simple. We have done in the last lesson. You can watch the previous video. But if you've forgotten, just remember this thing. You need to plug it over here. And what's the answer? In this case, it'll be 0 itself over here, the turning point. But since I know it's undefined, it'll be a sharp edge or something like this. Sharp edge or a corner. Or it can be like a cusp like this. So it can be like this. Or a sharp... now, since there is no absolute value, it is wrong of me to use that particular value. So I'll use this thing, something like this, okay? And then what is happening? It's down, decreasing. See, increasing, decreasing, and then again it increases, something like this. So there is a minimum point at what? 6 by 5. You can put x as 6 by 5 and you'll exactly get the value. What is the minimum point? But it's obviously negative value because from 0 it's coming down. It should be some negative value. This is the rough graph. That's the answer, guys. That's it. This is 0. This is 6 by 5. I hope it's clear. The same thing. It's just few steps. Derive the function first. Now we have got a rational function. So numerator is equal to 0. You get this. Denominator equal to 0. You get this. Then substitute. I mean, do this thing. I'm doing it directly, but in the textbook, they do 3 layers like 1 by 1. No need. Just follow what method I'm doing. It's much easier. And then what you have to do is try to do the approximate graph. Now, let's see the answer over here. Where is the graph? Look, this is the graph. It's not accurate. Now, mine is not that accurate, but you get understanding. That's the thing. Now, if you have 4 options, this is most likely like this. Other graphs will be entirely different. They won't match this at all. Okay. So if you have this basic understanding, it's more than enough to choose. If it's MCQ, if it's in writing, if you do approximate graph, more than enough, you'll get the full marks. That's how we basically do it. And this is all the details. Now, this you can write by in your own words the details. What is this details? Over here, from values 0 until minus infinity to 0, what is happening? It is greater than 0. It's increasing. See, plus means greater than 0. Where it's from minus infinity to 0, and let me just remove that. The same thing is over here. From minus infinity to 0, and from 6/5 to infinity, it's positive. So these are increasing. Derivative is greater than 0 means the function is increasing. And where is it less? From 0 to 6/5, it is less than 0, the derivative, that means function is decreasing. When the derivative is greater than 0, the function increases. When the derivative is less than 0, it decreases. That's basically it. Now over here you can see, right? This X mark denotes it's undefined. That's it. Over here they have written 0 because that was the numerator. This we got from the denominator. And the last problem now. We have done this already, not exactly, but this similar problem, the powerful problem, we have done it. Same method, do it by yourselves, and then you can check the answers. Please try it by yourself. Take some time, take your paper, and derive this, equate it to 0, find the x values, do the positive, negative, increasing, decreasing graph, and then try to graph it by yourselves. I hope you have tried it and solved it properly as well. Now, anyways, let's see how to do it. Derive this. It'll be 4x cubed plus 3 times 4 is 12x squared minus 10x minus 31. This is done. Now this is a polynomial function, so critical numbers will be at f dash of equal to 0. See, I'm not writing everything in detail. In the last lesson, we had written this. It will be either at equal to 0 or when it's undefined, and therefore we find the critical numbers. But now I'm just using short forms. And now we will just find the x values, equating this to 0. Directly use the calculator over here. In the textbook, it's mentioned you can use Newton's method. Yes, absolutely. Be my guest to use the Newton's method, but it'll take forever. It takes a long time. That's the reason I use the calculator over here. Now, this is cubic, so mode 4, and just put 4, 12, minus 10, and lastly, negative 31. And the answers are, okay, x is 1.5982, and what's the next one? Minus, okay, let me write the answers and let me just check whether this is correct or not. 1382, and this last one more, and it is minus 2.96, minus 2.9601. But anyways, let me just leave that. So let me just check whether I've put all the values correctly. I've derived it correctly. It's 4, 12, minus 10, and negative 31. Yes, it's correct. Okay, anyways, these are the x values. Now what you do is basically over here, do the increasing and decreasing graph, this one. Okay, that's not a straight line. Okay, this is fine enough. From ascending order, that means it'll be negative 2.96 first, and then it'll be negative 1.6, and let me write 6.4, and over here we have positive 1.6 because it'll be greater, so 1.6. Now let's choose the test values. What test values? I'll take minus 3, over here I'll take minus 2, over here I'll take 0, and over here I'll take 2. These are the test values to check whether it's positive or negative. If it's positive, it's increasing, the function increases. If the derivative is negative, anywhere if it's negative, the function decreases. The easy method is just type this equation, derived equation as it is. 4 alpha x cube plus 12 alpha x squared minus 10 alpha x minus 31. Calculate at minus 3. What happened? It's minus sign, it's negative over here. I'll just write the first one. So this one over here, let me write it in blue, is minus. Now next one, calc at minus 2. It's plus. Let's check the next one. Calc at 0. Minus. Minus plus minus. I think so it might be again plus. Calc at 2, and yes, it's plus. So usually they keep on changing. So that means all these are either maximum or minimum values. So plus, minus, plus. Here we know this is decreasing, increasing. Here it's a minimum value. Again, it's decreasing, increasing. Now this is it. Now we can graph. Let's just compare the graph directly. We have graphed it many times. We can see the graph. You can just find these values over here, put them in the graph over here. You'll find the accurate values and you can graph it accurately, as accurate it can get. These are the most important points of the graph, the critical numbers. That's it. Then the remaining end behavior is not so important because it keeps on going till infinity. Now let's look at the graphs solutions. These are all the correct values we have got. Yes, we have got these only. And yes, where is the graph? Okay, so here we have this. I will just erase the above part. So now we can see it more clearly. You can see whatever was less than negative 2. Okay, in this particular problem, what they have taken is they have taken this value as a, b, c. Can you see? A is negative 2.6, b is positive, c is positive 1.6. They have just assigned alphabetical values. That's fine, just because it will be much difficult to write these numbers. They have just assigned it. That's fine as well. Now you can see over here, less than b, it was increasing. So now look, I just got confused. This is the derivative graph. This is the graph which we need. Graph what? This function over here. First, see, where is a is negative 1 point, a is negative 2.96. Before that it is decreasing. Yes, it's decreasing. And till Paul negative 1.64, it's increasing. Yes, can you see this part? It's increasing. Then it again decreases until this point C, and then lastly it increases. Yes, this is all correct. And how do you find this? What is this value? How do you find it? Is very simple. Put these critical numbers over here. You can type this equation in the calculator and calculate at this point. You will get the value over here. We have done this in the last lesson. You will get exactly 51 or something. This is 52 or something, 55 or something. And this will be negative some value, negative 5 or something. This is how we graph it, okay? As accurately as possible. Now, even if you understand the basic, how it moves, that's more than enough. And this is x to the power 4, and yes, this resembles the graph of x to the power 4. Okay, this both side is going upwards because it's a parabola, but since it's to the power 4, here there is undulations. That's how we basically solve these problems. I hope it is clear, and that's the end of this lesson. I hope you have found this lesson helpful. If you have benefited from it, please do consider liking my video, sharing it with your friends. That would mean a lot to me. And if you have not yet subscribed, please do click on the subscribe button. You can just scan this QR code and subscribe to it. You can find a lot of other materials as well, MSAT material and other explanation videos on math. So please do try going through it and benefit from it. All the best and see you in the next video. Bye-bye for now.